Welcome to VW 7.3. Today we're going to be talking about this theorem right here, the irrational zeros theorem. So this is straight from your book. It says let f be a polynomial function of degree 1 or higher, and this is just some generic way to write any polynomial function. Now it says if p over q is a rational zero, meaning, this is important, if there is a rational zero, that's what that would mean. P must be a factor of a sub 0. So right here, your last term, we're going to say P is a factor of that. And then Q must be a factor of a sub n. So your first one, that's a sub n, it's saying Q is a factor. So that might seem really abstract. So let me give you an example here. Let's say here's our function, 2x squared plus 7x plus 3. If I told you to find the zeros, you would simply factor 2x plus 1, and then x plus 3. And you would tell me, well, the zeros are negative 1/2 and negative 3. And I'll put over 1 to make it fit our problem more nicely. What the theorem is saying is, if p over q is a rational zero, then p is a factor of 3. So p is a factor of this number. And then q is a factor of that number. So meaning, here's your possible values of p. So p right here. And then here are your possible factors of q. And you're seeing that here. P over q. Notice how p, the numerators, are 3 and 1. That's what this is saying. And then q, look, 2 and 1. And you're seeing that on the bottom. So that's kind of showing you an introduction to how the theorem is working. So for the first problem, it says list the potential rational zeros, meaning these are just potential. You're going to write p over q to help you. So here's your p, right there's your q. Put a big plus or minus, and then we're going to put a bracket like that. On the numerator, write all the possible factors of 6. So that would be 1, 2, 3, and 6. On the bottom, all the factors of 2, 1 and 2. Now let's condense that, so plus or minus. Let's do it methodically. So 1 over 1, that's 1. 1 over 2, that's 1/2. And just keep going. So 2, we already have 1. Then 3, 3 over 2, and 6. So here we have the potential rational zeros. It doesn't mean they all work, it just means they're potential. And also notice that this notation, this is kind of my shorthand. This is a way of representing 12 numbers. The book would just write plus or minus 1, plus or minus 1/2, plus or minus 2, and so on. But I write this just to save us some time. So right here, this is our answer. Those are the potential rational zeros. Let's try it one more time here. List all possible rational zeros. So remember, this is your p, that's your q. I recommend doing that at the beginning to help you. So p over q, that's plus or minus. Let's put a big bar here. So factors of 2 are 1 and 2. Factors of 15 is kind of a lot. 1, 3, 5, 15. So now we condense that, plus or minus. So let's start at the top. So 1, 1/3, 1/5, 1/15. Let's write that. And then so it's 2 now, 2, 2/3, 2/5, 2/15. And again, you have to understand that these are the possible rational zeros. Just what is possible. Doesn't mean they all work, just the possible. Okay, let's circle that. And now let's use the theorem. It says find the real zeros of that function, then write f in factored form. So to do this, we're going to use that theorem. So the potential zeros or your P over Q. So again, note P, Q, plus or minus. Factors of 6 are 1, 2, 3, 6. Factors of 2 are 1 and 2. So now we condense it. That's going to be 1, 1/2, 2, 3, 3 over 2, and 6. So notice it's the exact same problem we had up here. Same thing. What we need to do now is figure out which one of these or how many of these are going to work in this function. So to do this, I'm going to show you a strategy I like to use. What we're looking for is this. We need this to happen, where f of a is equal to 0, meaning we're going to use the factor theorem. Because if this is true, we conclude that x minus a is a factor. So my tip for all of you is going to be this. Start small and go up. Meaning we're going to plug in the small numbers and see if we get 0 and then work our way up. So there is a little bit of mathematical intuition here. So let's say I start with 1. If I plug in 1, I get 2 plus 11 minus 7 minus 6. Notice how that does get 0, so we put a happy face, that's great. Therefore, x minus 1 is a factor. That's huge. So basically, once we get this, we're good to go. Because that means now I can do my synthetic with 1. So I put 1 right there. Let's put the function down like so. And notice how we're going to use synthetic division. We drop the 2, multiply. That's 2, 13, multiply. That's 6, multiply. And then 0 with our happy face. So now we interpret. That's x minus 1 times 2x squared plus 13x plus 6. That should equal 0. And that thing can be factored. So now I have, that's 2x plus 1 and x plus 6. So x must equal 1, negative 1/2, or negative 6. So there are the zeros, and then it also says write f in factored form. So we'll say, I'll put that over here, f of x. The factored form would be, you could leave it like this. What our book likes to do is factor the 2 out. So they'll do like 2x plus 1/2, x minus 1, x plus 6. So this would be your factored form. Hey, let's try a harder one. This one's going to be 4th degree. So first, we're going to start with our potential zeros, our P over Q. So plus or minus, remember here's your P, here's your Q. Q is 1, so that's convenient. So I know it's just going to be plus or minus 1, 2, 4, or 8. Okay, now we got to check. So let's plug in 1. So f of 1, that's going to be 1 minus 1 minus 6 plus 4 plus 8. Already we can see that this is not going to be 0, so that means 1 doesn't work. So at this point, what I'm going to do is make that negative 1. let's check negative 1. That's going to be 1 plus 1. That's going to be minus 6, minus 4, plus 8. And we're going to see that would be 2 minus 10 plus 8. That is, in fact, 0. Which means, therefore, x plus 1 is a factor. So negative 1 worked. Okay, that's really good. So now we're going to use that. Negative 1. And then let's write our synthetic down, our coefficients. 1, negative 1, negative 6, 4, and 8. We drop the 1, so negative 1, negative 2. It's going to be positive 2. That's 4, 8. Okay, so the 0 worked. That's great. So in the event you get this to be 0 and this is not 0, that means you must have made a mistake, because if this is 0, this has to be 0 here. Now the issue here is this still isn't that helpful because this is x cubed, which means if we call it, let's say, I'll put a bar here, our new problem is now, well, now we have this new g of x, that's x cubed minus 2x squared minus 4x plus 8. This thing we got to solve and figure out what numbers are going to work. So you could try 1 or negative 1, because negative 1 worked here, but we know not to try 1. 1 doesn't work because it didn't work earlier, so there's no way it's going to work now. So you could try negative 1 again, but we can see negative 1, that is not going to work here. So let's move up to 2. G of 2. So plug in 2, that's going to be 8 minus 8 minus 8 plus 8. That's very convenient. So now I can see that's crossing out. So g of 2 equals 0. Therefore, x minus 2 is a factor. So now we come back to this thing, do synthetic again. 2. Drop the 1, multiply, add. We multiply. Let's add, multiply. Excellent. So now we interpret this. So the first factor was x plus 1. The second factor was x minus 2. And then this is going to be x squared minus 4 equals 0. And now we can solve it. The zeros are x equals negative 1, 2, and negative 2. Now if asked for the factorization, we could say the factorization is f of x equals x plus 1, x minus 2 squared times x plus 2. And that would be your factorization. And that's it.